thank you for joining us. I'm going to have the second video of the notes on working with the law of cosines, also known as the cosine rule. Okay, so if we want to solve the triangle and we're given this information for our triangle, our best situation is to draw out what we have. We've got a 108-degree angle. We have a side of 56.1 that is opposite angle B. We have a side of 77.9 that is opposite angle C. And we need to figure out the rest of the information. Okay, so in order to do this, we've got side angle side, so we can start with our cosine rule. Okay, so I'll call this x. I know x squared is going to be 77.9 squared plus 56.1 squared minus 2 times 77.9 times 56.1 times the cosine of 108 degrees. Okay. So I want to be careful. I'm in degree mode. All right, let me come up to my calculation. Let's clear this out. So 77.9 squared plus 56.1 squared minus 2 times 77.9, close parentheses, open parentheses, 56.1, cosine of 108 degrees. All right, so that's x squared, which is approximately 11,916.54596. So if I take the square root of that answer, square root of that answer is approximately 109.2. So that's my side. But it says solve the triangle, so I need to also find my angles. So what's my next piece? Well, I need to find the angles. So what can I say? I know that the sine of angle B all over 56.1 must be equal to the sine of 108 degrees all over that 109.2. Okay, but notice that tells me that the sine of angle B, right? How I'm going to make this computation, I'm going to have 56.1 times the sine of 108, close parentheses, then divide by that 109.2, which was my previous answer, and that gives me 0.488758 approximately. All right, so the inverse sine of that answer will be my angle beta. And that gives me beta as approximately 29.3 degrees. Okay, and then I need to find the last angle. So angles add up to 180. So 180 minus 108 minus 29.3. That gives us the angle C is approximately 42.7 degrees. And now I have solved the triangle. I have the three sides and I have the three angle measures. Okay. If I look at my situation over here I see that I have side, side, side. So that tells me the cosine rule. And I'm always going to want to do the work with the longest side first. So that tells me that 13 squared is going to be 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of angle A. So that means that the cosine of angle A is going to be 13 squared minus 8 squared minus 11 squared, which is negative 16. So negative 16 all divided by negative 2 times 8 times 11, which is negative 176. It looks like, okay. So that means that A is going to be the inverse cosine of that negative 16 divided by negative 176. So that's 0.09 or 1/11. And so if I do the inverse cosine of that value, that gives me 84.8 degrees approximately. So angle A is approximately 84.8 degrees. That's my largest angle. Okay. Then I can solve for the rest of the items. So here is beta. So I know that the sine of beta all over 8 is going to be the sine of 84.8 degrees all over 13. That means that the sine of beta is going to be 8 times the sine of my answer, because that's my angle, divided by 13, which is 0.6128 approximately. So take the inverse sine of that. That gives me 37.8 degrees. That should be my smallest angle. And my angles add up to be 180 degrees. And so that gives me the angle C then is about 57.4 degrees. So I've got a problem that I start with the law of cosines. Once I find the angle, I can use the law of sines to finish solving the triangle. All right, continuing. We have a word problem that has a pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. The pitcher's mound is not halfway between home and second. How far is the pitcher's mound from first base? So let's draw out our situation. So we have a pitcher's mound. We have home plate. And we have some distances. So I want to figure out the distance from here to here. I'll just call that distance x. Okay. Now, an important thing to distinguish here is to understand the information that we're provided. Okay. So this pitcher's mound is not halfway, so I'm going to say that I have something like that. All right, and so that's 43. I want to figure out that length, but I don't have other information but I want to figure out other information. So how far is the pitcher's mound from first base? Well, it's important to understand my angle over here, that I have 90 degree. I've got 90 degrees for this softball diamond, okay, where the side between each piece is 60, where the distance between each base is 60 feet. So I can label my piece to 60. All right, and this angle in here, because this does split in half, the 90-degree angle, I know that this angle right in there is 45 degrees. So what does that tell me? That tells me that x squared is going to be 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. All right, I'm in degree mode. Let me go ahead and make those computations. 2 times 43 times 60 cosine of 45 degrees. And so that tells me that x is approximately the square root of 1800. And if I take the square root of my answer, that gives me that x is approximately 42.4 feet from first base, right? The pitcher's mound. Right, so the pitcher's mound is about the same distance from home plate as it is from first base. And in fact, that is how a softball field is set up. Okay. Next application problem. We have a submarine and it sights a moving target at a distance of 820 meters. So I don't know why that says 82. Right, so this should say 820. Torpedo is fired, right, 171.66 meters ahead of the target and 924 meters from the submarine as shown below. Find the angle, right? So we want to find this angle theta at which the torpedo was shot. Okay, so we don't know necessarily this angle over here, but we do have 3 sides. So I want to find that angle. What do I know? 171.66, which happens to be my shortest side. That number squared must be equal to 924 squared plus 820 squared minus 2 times 924 times 820 times the cosine of angle theta. Okay. Now, I'm going to do a little something just to check to see if this is a right angle. Well, I can try the Pythagorean theorem. I can say 820 squared plus 171.66 squared gives me that number. If I take the square root of that, I get 837, which is not 924, which tells me this is not a right triangle. So we know it's not a right angle, so we have to use the law of cosines. We can't use anything else. All right, so continuing with this, I know that the cosine of theta must be equal to, I'm going to have 171.66 squared minus 924 squared minus 820 squared, all divided by negative 2 times 924 times 820. And so the cosine of theta is approximately 0.98769. Right, so my inverse cosine of that tells me that theta is approximately 9 degrees. Right, and that should make sense that 171.66 is much smaller than 820 and 924, so a small angle makes sense in this context. So that's applying the law of cosines in a variety of ways. Drawing pictures is difficult. You want to be careful with your work. Make sure you do your practice. Make sure you prepare well. You ask questions for clarification as needed. Thank you for your time.